Hello everyone. In this video clip, I'm going to discuss a past year question on vector. Now this question is a question in SPM 2016, question number 5. Okay, let's see how to solve this question. This is a HOTS question because it combines the vector in additional maths with the resultant force that we learned in physics. So over here, let's read the question. Diagram 5 shows the position and the direction of boats A, B, C in a solar boat competition. And the boat A and B move in the direction of the water current, and the velocity of the water current is given by W. So let's mark it down. So W equals to I plus half J. Now this is a position vector. I prefer to write in a form of column because I do not need to keep writing I and J repeatedly. So the velocity of boat A is given by A, and the vector is 2, 1. And for B, the vector is 6I and 3J, so 6, 3. Okay, so how do we solve part A? Part A wants us to find the resultant velocity of boat B and its relationship with the resultant velocity of boat A. Now, to solve this question, we need to understand the resultant force. Given the force 1 moving towards the right, on top of that, we have another force act upon the same object, but in the same direction. Therefore, the resultant force will be taking the F1 plus F2. So likewise, in this question, in order for us to find the velocity, okay, the resultant velocity of boat A, we just need to take the velocity of the boat A itself plus the help of this velocity of water current, which help to increase, to speed up the movement of the boat A. Okay, so in that case, A is 2, 1, and W is 1 half. So on and on, we will have 3 and 3 over 2 because 1 plus half is, if changed to improper fraction, is 3 over 2. So we have done with the resultant velocity of boat A. Now we do resultant velocity of boat B. So boat B we will need to take the velocity of the boat itself with the help of the water current. So the B will be 6, 3. The water current is 1 half. All in all, we will have 7. 3 and a half is 7 over 2. Okay, so let's find out how many times of boat A compared to boat A, boat B compared to boat A. So their relationship is VB equivalent to lambda VA. Okay, because the boat B must be moving faster. By looking at the speed of the boat itself, B is faster than A, but how many times faster? So they are since they move in the same direction, so they must be parallel. If they are parallel, they will be connected with this, okay, velocity VB equals to lambda VA. So we are using the concept of parallel. Okay, therefore, let's just put the VB in, 7 over 2. Equivalent to lambda 3 over 2. When we reach here, always compare coefficient. Compare coefficient. So isn't it that we are applying the steps that we learned in vector? Once they tell you the two vectors are parallel, we write out their relationship, and then we need to find out what is the value of lambda by comparing coefficient. These two steps are very important in vector, in solving the vector question. So compare coefficients. So for our unit vector in the direction of x-axis, the coefficient will be 7 equals to 3 lambda. So over here, we will have lambda equals to 7 over 3. And we can cross-check it with a unit vector in the direction of y-axis. So we will have 7 over 2 equals to lambda 3 over 2. And then therefore lambda equals to 7 over 2. Bring over 2 over 3. After we simplify, we get back 7 over 3. That means lambda exists, that the resultant velocity of B is parallel. Okay, the vector is parallel. How many times? 7 over 3 times of resultant velocity of A. Or we can change it to a mixed number, 2 and 1 over 3 of BA. Therefore, we can answer the question, part A, that it is 2 and 3 times. Okay? Or you can just leave this as our answer. So VB is 2 and 1/3 time of the resultant velocity of A. So that's the answer for part A. Now let's see the part B question. B, on the way to finishing line, boat C is facing a technical problem and off track. So the velocity of boat C is 2 minus 3 over 2. So I would prefer to write in the form of column 2 negative 3 over 2. And we need to find the resultant velocity of boat C. So we use the same concept. Okay, we use the same concept. We just apply directly. So in B part 1, the resultant velocity of boat C, we just take the C plus the W. Okay, whether the W speed up or slow down in the vector, in the calculation of vector, it will auto deduct, add together. So we will have 2 negative 3 over 2 plus 1 and half. Yeah, our W is 1 half. So all in all, we will have 3 negative 3 over 2 plus 1 over 2. We will have negative 1. Okay, so the resultant velocity, let's write it back in the position vector, 3I minus J meter per second. That is our resultant velocity of B. And then part 2, the unit vector. So we need to find the unit vector of the boat C. Okay, that means we've got to find this one. The symbol like this, whereby we need to take the vector of a resultant velocity of boat C over the magnitude of it. So we will have, again, 3 negative 1 is the vector, and then over the magnitude, yeah, so it's 3 squared plus negative 1 squared, and then square root. So we will have 3I minus J over third 10. This will be the unit vector in the direction of boat C. That's it for this question. So the difficult part basically comes from our understanding about the resultant force of physics. Once you get it right, then the rest is just the normal calculation that we learn in the vector chapter. Okay, that's it for this video. I hope it helped you. Anything, you just leave your comment, and then I try to answer your question as soon as possible. Thank you very much.